So we'll cover 8.2 and 9.2 this week. And then next Friday, which is April 1st, there will be an exam over the two sections in Chapter 7 and then 8.2 and 9.2. And we'll review just like we did for the other exams. We will have part of it in class and part of it take home. Any questions?
When should the take-home test portion be due? April 1st as well?
It'll be due that Sunday night, so the 3rd.
Okay, sounds good. Thank you.
And I try and put it up by Monday. That way you have time. If you're busy that first weekend of April and you want to start it the weekend before, just let me know. We could do that too. Sure. Any questions? Okay, 8.2 deals with critical numbers and relative max and mins. So I'm going to give you a couple definitions first. So the first one is a critical number. And I talked a little bit about it when we were using it in earlier sections, but I didn't actually give you a definition. Critical numbers are where there are highs and lows in your graph. They're the numbers in the domain of f of x, where the derivative is 0. So there any value when you take the derivative and set it equal to 0 that you get. Those are critical numbers. It's also critical numbers where C does not exist. In the domain. But the critical numbers, if we look at the problem here, the low values or the high values, those would be critical numbers. So if we took the derivative of this function and set it equal to 0, we would get, well, looks to be about 1.5 or maybe 1. Over here, we'd get 4. So when you set it equal to 0, it's giving you the x value that will give you a high or a low on your graph. So anytime you're asked for a relative max and min, absolute max and min, you need to find your critical numbers first. A relative max or min occurs at a critical number and the endpoints of the domain. So if we look at f of x equals 2x cubed minus 3x squared minus 36x plus 4 from negative 5 to 10. So this would be our domain. If we want to find our critical numbers, you take the derivative and set equal to 0. Two times 3 is 6x squared minus 6x minus 36. So if I took the derivative of this, I would get this. Any questions on the derivative? Now I want to set it equal to 0 and solve. One way of solving, quadratic formula, because it's x squared. Another way is to factor. Now, factoring when you have a number in front is a little more complicated, but notice this is all divisible by 6. I can get a lot smaller numbers. As long as you have an equation, you can divide it out. Otherwise, you'd have to factor it. So we need two numbers that when we multiply, we get a negative 6. And when we add, we get the middle one, which is a negative 1. Anyone?
Negative 3 and 2.
Negative 3 and 2. When we multiply, we get the negative 6. When we add, we get the negative 1. Since there's no number in front of our squared term, it's just 1s. So it's x minus 3 and x plus 2. If you have quantities multiplied together that equal 0, then one of those quantities has to equal 0. So you can set each of them equal to 0. Add the 3. And subtract the 2. So we have two critical numbers. Now, the next, they do it in this one or not? I think it's the next section, but the critical numbers need to be on your interval. A lot of this chapter doesn't have an interval, but for the graph part, I wanted you to see it. So to see whether an endpoint is a max or a min. And that's why I used an endpoint. But when you are finding critical numbers and you have an endpoint, these numbers need to be between here. And negative 2 and 3 are both between negative 5 to 10. So these would both be critical numbers along with your two endpoints. Well, max and mins. Now to see if they're a max and a min, one way of doing that is to graph it. When you're graphing, look where your derivative is and use the equation before. Most cases it's the original, but sometimes, for instance, if we were given revenue and cost and we found profit first and then took the derivative, you want to use the profit, not the revenue or the cost. So rule of thumb, look where your derivative is and take the equation before it. So we're going to graph this equation. So we're graphing the one that I circled. Y equals 2x cubed minus 3x squared minus 36 x plus 4. Now remember, when they give us a bound, we could use cursive, -5 less than or equal to x less than or equal to 10. There we go. Oh, almost. My x values went from -5, so I'm going to go -7 to 10, so I'm going to go 12. There we go. Now we can see it a lot better.
What did you just do? What did you just do there?
Mhm.
What did you do
So
there?
I knew that my range was -5 to 10, and I wanted to get it spread out more. So you click on your wrench, and then I went 2 units each way. So I went, instead of -5, I went -2. And then instead of 10, I went 12.
Okay. Thank you.
Now, I also noticed that this low value is not showing. So I could change the -y to let's see, 43, maybe 50 will do it. No, a little more. 60. But it's close. Let me see where it's going. So you can move it and see. So if I went to -80, then I would see all of it. So I can go back to my wrench and put in -80. I moved to my top one. But what's my top going to? 50. There we go. So if you find where your high and your low is, for the high and the low, the y value, then you can adjust your y. For the x, I go a little bit larger and a little bit smaller than my domain. If you're not given a domain, then it's up to you how far you would go. Then if you click on this graph, it will show you the intercepts, but it also shows you these highs and lows. And if you click on it a second time, it keeps the value. Notice we had gotten -2 and 3. -2, 3. This one would be a max because it's a high point on the graph. So it's called a relative max. Relative max of, and then you give the y value, which is 48, at x equals -2. The other one, the critical number we found that was a 3, that's a low point on the graph because it's the other values next to it are higher. So this is a min. There's a relative min of -77 at x equals 3. So when you're giving these, you need to state whether it's a min or a max and at what value it is. Now to find the endpoint, like at -5, we could put x equals -5, and it will show us it's down here. So I need to move down. Whoops. Oh, I had it divided by sign. That messed it up. There it is. It's intersecting down here. At -5, -140, -141. Now, this one, notice that the red graph is going like this. So at -5, this is a min. So an endpoint can also be a relative min or a relative max. 10 would be over here, the other endpoint. So this one would be a relative max. This would be a relative min. Any questions on that? So a relative max or min can be your critical numbers or your endpoints. Any questions on that? So then on this one, there'd be a relative min of a -141 at x equals a -5. If we wanted to find the other endpoint, the 10, click here, and we can put x equals 10. And then it's that green line, so now we need to see where the green line intersects the red. So we'd move up, pretty far up. It's right around here. There it is right here. 10, 1344. So that's a max because the rest of the line is going below it. And so it would be a relative max of 1344 at x equals 10. Any questions on that? So critical numbers, and if you have endpoints, those can all be relative max and mins. Any questions? Any questions on how to tell if it's a max or a min? I think the endpoints is where the most questions usually happen. Because if this kept going down, it wouldn't be a min. But since we don't know what it's doing, it's the lowest point in this section, so it's a min. And in this section, it's the highest one, so it's a relative max. Any questions on that? Okay, let's try some problems. This one, oh, I know. I didn't want to close it because we're going to use it again. Okay. Find the location of values of all the relative extrema. Now it says to compare with section 8.1, but we didn't really cover 8.1. 8.1 talks about increasing and decreasing. For instance, this would be decreasing, and then at the critical number, it would start increasing, because a critical number is also where your graph changes from increasing to decreasing or decreasing to increasing. It's where it changes. And so if it goes down and then up, that's a minimum. So there's a relative min of 2, 3, -4 at, I think it's 1.5. But this would be a relative min. Any questions on that? So this one would have a max. Now the endpoints wouldn't count because instead of closed circles, those are arrows. They keep going. So you could only do the relative min. Notice when it's a parabola, it has only one. And this would be the absolute min, which we talk about in the next chapter. This one would be a relative max of, and then you put the y value, which is 1, at x equals 4. Any questions so far? Okay, let's go ahead and try number 5. Find any max and mins. So this first one, the most left, will it be a max or a min? Anyone? A max, yes. So it'll be a max because it's a high point. Everything around it is below it. It's a mountain. A low point or a min would be a valley. So this one is a max and it's at 3. So there's a maximum of 3, the y value, at -4. Any questions on that part? Okay. The other one is going to be a min because it's a valley. So there's a minimum of the y value, which is 1, at the x value, which is -2. So our two critical numbers are -4 and -2. So critical numbers are the x values. Any questions on that? Okay, let's look at number 8. Number 8, notice that there are 2 mins and the minimum value is the same, it's 0. So a lot of times what they'll do is a relative min of 0, and then it's at 2 points. X equals 3 and -3. So when there's a low and it's the same value, then they'll put them. If it wasn't the same value, you'd have to write them separately. But since they both go down to 0, you can write them together. Now this one here, even though it's not bending like a parabola, it's at a point, it is still a max because the values around it are lower. So it would be a relative max of 1, 2, 3, 4 at x equals 0. Any questions on that? Okay. Number 13. Find the x value of all points where the function defined as follows have extrema. Find the values of any relative extremas. So we want to, I'll do 13 first. Find the values of any relative extrema, the x value. That means critical numbers. So to find them, take our equation. We take the derivative and set it equal to 0. Taking the derivative, 2x minus 10. Set it equal to 0. Add the 10 over. And divide by 2. So 5 is a critical number. Well, is it a max or a min? Well, one thing, if you know your graphs, we know that the original x squared is a parabola. And we know because the x squared is a positive 1 for A, that it's a parabola going up. So we don't even need to graph it. We know that this is a min. Because the critical number is where you're increasing and decreasing change. A parabola going up, it's a minimum. So there's a relative min of, and then the y value, at x equals 5. So some of these you don't have to graph the equation if you know what they look like. Any questions on that part? So we could graph it. Another way of finding the y value, if you don't graph it, you plug this into the original. So y equals the 1 before the derivative, 5 squared minus 10 times 5 plus 3. Negative 22. So you plug it into the same one you would have graphed, the one right before the derivative. Now we'll graph it and you can see, but is there any questions on that? So if we go to Desmos, and we graph it. Now you want the one before the derivative, so y equals x squared minus 10x x squared and we have our parabola. Five, negative 22. Excuse me. And we know it's a minimum because the lines on each side of it are higher. Any questions on that? Let's try another one. Let's try 17. Negative 4/3 x cubed minus 21 over 2x squared minus 5x plus 8. So to find the relative extrema, that means relative max and min, we take the derivative and set equal to 0. So 3 times negative 4/3 is a negative 4x squared. 2 times 21/2 is a negative 21x minus 5. Any questions on that? Now, would you factor this or would you use the quadratic formula? Anyone have a preference?
Quadratic.
Okay. So A would be negative 4, B is negative 21, and C is negative 5. Nice thing about the quadratic formula is it always works and you don't have to think about it. But this one is factorable if you want to factor. I did write it right, didn't I? Yeah, they're all negative. So negative B plus or minus the square root B squared minus 4 times A times C all over 2 times A. I always calculate under the radical first. $361 is a perfect square root. It's 19. So it'd be 21 plus 19 over a negative 8 and 21 minus 19 over a negative 8. So we get 5 and either 1/4 or 0.25. So these are our two critical numbers. Any questions on that?
Is
Now, of
it,
course,
sorry, is it negative 1/4 or 1/4?
let me double check. 21. Oh, it should be negative. I think I just didn't put my sign in. Yeah, thank you. It is negative. Now, we know this is a cubic graph that resembles a snake. We know it's negative, so it starts out decreasing. So when we're graphing this, it's going to change direction twice because there's two critical numbers. It's going to go down and then change direction and then go up and change direction. There's two critical numbers, which means that first one, this one, the negative 1/4, that's going to be a min, and the 5 is going to be a max. So by knowing the graphs, you can figure out pretty easily whether it's a relative max or min. But if we graph it, look where your derivative is and do the one before it. This one. So we'll clear the one that's there. We want negative 4/3 x cubed negative 21 halves x squared minus 5x plus 8. And there's our graph. Now you can close this. There we go. If we click on it, it gives us our values. Oh, they should both be negative. I forgot to divide by a -8. I only used positive. So these are both negative. Now by making your graph, it's a little easier to see that. And then you can see that this is a minimum. So there's a minimum of a -63 at -5. And there's a relative max of 8.6 at -1/4. Any questions on getting those values? And then by doing the graph, it helps make sure you don't make a mistake. On the in-class portion, if I did one like this, I would probably give you the graph. So notice, yeah, my graph's right. I would give you the graph and you'd have to tell me which would be a min and a max. So you'd have to find the values and then look at this graph. But you wouldn't be able to give me the points then. So I probably would do more of the story problems in class. And then the take home, there'd be one like this. Is there any questions on it? Let's try another one. Thought there was. Now you need to be careful if you're just trying a bunch of problems because some things like this one here, number 21, this is a power rule. We didn't learn that. And we haven't learned exponential and logarithms. So there are some that we haven't learned. You need to be careful. There was one I did earlier. Oh, 19 and 20. Okay, we'll do 19. Because it's a little different when you're finding the values. So we have f of x equals x to the 4th minus 18x squared minus 4. So we want to find our critical numbers by taking the derivative and setting it equal to 0. We have 4x cubed minus 36x. And the 4 goes to 0. Any questions on that part? Okay, so then we want to set it equal to 0 and solve. Now you can't use the quadratic formula because this isn't quadratic, it's cubic. But we can factor an x out. In fact, we can factor a 4x out. If we pull out an x from here, it leaves x squared. And we pull 4x from here, it leaves a minus 9. Any questions on that part? No, there's probably 3 ways you can solve the x squared minus 9. One, you could use the quadratic formula. B would be 0. Another way of doing it is factoring this. And another way is the square root method. Anyone have a preference? because we factored this, we can put 4x equal to 0 and x squared minus 9 equals 0. Dividing by 4, we get 0. If we add the 9 over and then take the square root of both sides, we get x equals the square root of 9 is 3. But what you have to be careful of, anytime you take the square root of both sides, it leaves a plus and a minus. This was 4. Most cases, if you subtract 1, you'll have 3 critical numbers. Sometimes they're a duplicate, but in most cases, you'll have 1 less than your degree. So we have 0, 3, and negative 3. The other way, if you would have factored it, it factors into x minus 3 and x plus 3. So then you would have got your 0, your 3, and your negative 3. Either way, and then if you use the quadratic formula, b would be 0. Any questions on finding the critical numbers? So all of those are critical numbers. Now define if they're a max or a min, we would graph them. Go where your derivative is and graph the one before. So we want to graph this. Y equals x to the 4th minus 18x squared minus 4. And there's your graph. Now we could spread it out a little if you want. But when you click on the graph, it will show you the highs and the lows. And then if you click on it again, it will hold the point there. Notice our critical numbers, negative 3, 3, 0. Now on the in-class portion, you will not be using Desmos, so you need to be able to find them this way. You can't just rely on your graph. We look at the first one, negative 3. Notice both of these are at a negative 85. So there's a relative min of negative 85 at 2 values. So there's a relative min of a negative 85 at 3 and negative 3. Our other critical number, 0, notice it's a high point because the values around it are below it. So there's a high or a relative max of the y value, which is negative 4 at x equals 0. Any questions on those? Awesome. Let's try 27 or 28. We'll try 27. So for number 27, we have to use the quotient rule. So to find our critical numbers, top, bottom. So it's the bottom. And then take the derivative of the top. 2x minus 2 minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. Any questions on taking the derivative? Now we will want to simplify the top, so I'm going to FOIL this. 2x squared minus 2x minus 6x plus 6, and then distribute a negative 1. All over the bottom squared. Combine like terms. X squared. 2x and 2x cancel, but leave a negative 6x. 6 minus 1 is 5. So that's our derivative. Now to find the critical numbers, remember you set it equal to 0. When you have a fraction and you set it equal to 0, the denominator cannot equal 0. So we know that x minus 3 cannot equal 0, which means x cannot equal 3. This is a critical number. So anytime you have a fraction, any values that have to be omitted are critical numbers. Sometimes they're not needed, especially if it's already omitted here. But in some cases, like average cost, some cases it's critical. Okay, so one of our critical numbers is 3. Now, as long as this isn't 0, we could just multiply it to the other side. Notice then, we're just setting the numerator equal to 0. So if you have a fraction, the only way it's going to equal 0 is if the top is 0. Then we want to factor it. Two numbers, when we multiply, we get 5. That when we add, we get a negative 6. 5 and 1, both negative. X minus 5 and x minus 1. Because when you multiply them, you get the 5. When you add them, you get a negative 6. Setting them equal to 0. We get 2 critical numbers, 2 more. Oh, I guess I could just put them with that one. So 5, 1, and 3. Any questions on that? Okay, if we graph it real quick, y equals x squared minus 2x plus 1, x squared. It's not, I didn't click. Y equals x squared minus 2x plus 1. And I'm going to put this in parentheses. That way when I hit divided by, it'll put it all on the top. X squared minus 2x plus 1 and x minus 3. And here's our graph. The 1 and the 5 are relative max and min. So this one would be a relative max. This would be a relative min. The 3 that's an asymptote. It's a line going through here. So it won't give us a max or a min. Sometimes it does, but because it's also omitted in the domain, because it would give us 0 in the fraction, it ended up not being a max or a min, but it's still a critical number. Any questions on that? Positive.